Welcome students. Today in this video lecture I will discuss on the topic surface tension. Now before starting the lecture I want to share some interesting picture with you. This is a small spherical dewdrop. Here these are some small raindrops. Here you see a needle. It is floating on the surface of water. The insect is walking on the surface of water. These are spherical bubbles. Now, behind all these phenomena, there is a property of liquid. That property of liquid is surface tension. Now, what is surface tension? The property of a liquid by virtue of which the free surface of the liquid at rest tries to minimize its surface area is called surface tension. অর্থাৎ কোনো তরল তার যে ধর্মের জন্য তার পৃষ্ঠতলের ক্ষেত্রফল সংকুচিত করতে চায় তরলের সেই ধর্মকেই বলা হয় সারফেস টেনশন। Due to surface tension, liquid surface behaves like a stretched membrane. অর্থাৎ তরলের এই ধর্মের জন্য যে কোনো তরলের উপরিতল একটি টান টান রাবারের পর্দার মতো কাজ করে। Now we shall try to define surface tension in terms of force. This is a container which is containing some liquid. Now, if I consider an imaginary line on this liquid surface, then on the both side of this line, there will be some force acting. These force are perpendicular to the line and these are tangential to the plane of the liquid. Now, this force per unit length is called surface tension. So, if an imaginary line is drawn on the liquid surface, the force per unit length in the tangential plane to the surface and in a direction perpendicular to the line drawn is called surface tension. অর্থাৎ তরলের উপরিতলে এটি কাল্পনিক রেখা টানলে ওই রেখার দুই দিকে লম্বভাবে এবং তলটির সাথে স্পর্শকীয়ভাবে প্রতি একক দৈর্ঘ্যে যে বল কাজ করে সেই বলকে আমরা বলবো সারফেস টেনশন। So the expression of surface tension is T equal to force over length. The SI unit of surface tension is Newton meter inverse. In CGS unit will be dyne per centimeter or dyne centimeter inverse. Now the dimension of surface tension, it is given by mt to the power minus 2. Now few examples based on surface tension. The small water droplets or raindrops are spherical in shape due to surface tension. Due to surface tension, liquid surface always tends to minimize its surface area. Since for a given volume, spherical shape has minimum surface area, so any small liquid droplet tends to be spherical. Now here it is to be noted that for small droplets, gravitational force is negligible. If we take large water droplets, in that case the gravitational force will not be negligible and due to gravitational force the spherical shape may be deformed. Now another example, when mercury is placed on a clean glass plate, it forms globules. Why? This is also for surface tension. Here also the gravitational force is negligible. Next, you see this needle. I am keeping this needle on the water surface, and interestingly, it is floating on the surface of water. Now, you know that normally the material of the needle is heavier than water. In spite of that, it is floating on the water surface. This is also due to surface tension. This is the cross-sectional view of the needle. The surface tensional force acts along this surface and also along this surface. So for these two surface tensional force, there is a resultant force. This resultant force balances the weight of the needle. Now I am discussing cohesive and adhesive force. What is cohesive force? It is the force of attraction between molecules of same substance. Here, this is one water molecule. This is another water molecule. Now the force between these two water molecules, it is cohesive force. Now, what is adhesive force? Now, it is the force of attraction between the molecules of different substances. Here, this is water molecule and this is the material of the container. Now, the force between these two, that is adhesive force. Now, some example based on cohesive force. We know that two drops of liquid coalesce into one when brought into mutual contact. Similarly, we know it is very difficult to break a drop of mercury into small droplets. This is also due to the large cohesive force between the mercury molecules. Now, this cohesive force is very strong in solids. For this strong cohesive force, solid substances have definite shape. This force is weak in liquids and extremely weak in case of gaseous substances. Now, few example on adhesive force. We can write on the blackboard with chalk due to presence of adhesive force between them. অর্থাৎ আমরা যখন চকের সাহায্যে ব্ল্যাকবোর্ডের উপর লিখি তখন ব্ল্যাকবোর্ডের মলিকুলের সাথে চকের মলিকুলে যে আকর্ষণ বল কাজ করে সেই আকর্ষণ বলের জন্য আমরা লিখতে সামর্থ্য হই। Similarly, a piece of paper sticks to another due to large adhesive force between the paper and the gum molecules. Next, angle of contact. The surface of liquid near the plane of contact with another medium is in general curved. Now, at the point of contact, the angle between tangent to the liquid surface and tangent to the solid surface inside the liquid is termed as angle of contact. That's mean যদি এই বিন্দুতে আমরা তরলের উপরিতলে একটি স্পর্শক টানি এবং যদি সলিডের সারফেসে একটি স্পর্শক টানি এদের মধ্যে যে কোণটি তৈরি হবে that angle is called angle of contact. Similarly here, this is the tangent drawn to the liquid surface, this is the tangent drawn to the solid surface, and the angle in between these two is the angle of contact. Now, the value of this angle of contact may vary from 0 degree to 180 degree. Here in the first case you see it is less than 90 degree, and here in this case we see this is obtuse angle. For different pair of liquids this angle will vary between 0 degree to 180 degree. Next, capillarity. If a tube of very small inner radius, the tube is called capillary tube. Now this tube is dipped in a liquid. It is found that the liquid in the capillary tube either rises or falls relative to the surrounding liquid level. This phenomena is called capillarity. Here you see this case that the liquid rises up through this capillary tube. When this happens, now if the angle of contact between the material of the tube and the liquid is acute, then the liquid will rise up through the tube. This is called capillary rise. Next, if the angle of contact between the material of the tube and the liquid is obtuse, then the liquid will fall down to the tube. This is called capillary fall. Now, the formula for the capillary rise, it is given by H equal to 2t cos theta over r rho g. Here theta is the angle of contact between the liquid and solid, r is the inner radius of the capillary tube, rho is the density of the liquid, and g is the acceleration due to gravity. From this formula, it is clear that for a particular pair of liquid and solid, H into R equal to constant. Why? For a particular liquid, T is constant. For a particular pair of solid and liquid, theta is constant. Density of the liquid is constant. G is also constant. So the product H into R, that will be constant. Therefore, H is inversely proportional to R. So we may write the ascent or descent of a liquid in a capillary tube is inversely proportional to the inner radius of the capillary tube. অর্থাৎ তরলের আরোহণ বা অবরোহণ কোনো টিউবের মধ্যে টিউবের ব্যাসার্ধের সাথে ব্যস্তানুপাতে পরিবর্তিত হয়। This is Jourin's law. Next, surface energy. What is surface energy? The molecule on the surface of liquid experience a net inward force. So, to bring a liquid molecules from the interior of the liquid to the free surface, some work is required to be done against the intermolecular force. This work will be stored as potential energy within the surface molecule. অর্থাৎ যখন আমরা কোনো লিকুইডের মলিকুলগুলিকে তার ভেতর থেকে বাইরে আনার চেষ্টা করব বা পৃষ্ঠতলে আনার চেষ্টা করব, তখন আমাদেরকে কিছু কাজ করতে হয়। সেই কার্যই তার মলিকুলগুলোর মধ্যে স্থিতিশক্তি হিসেবে সঞ্চিত হয়ে থাকে। Now, the potential energy of the molecules per unit surface area is called surface energy. It can be shown that the work done or total potential energy is equal to the surface area into surface tension. So from here I can show that surface energy per unit area will be equal to capital T. Unit and dimension of surface energy, the SI unit will be joule over meter square and CGS unit will be arc per centimeter square, and the dimension will be m t to the power minus 2. Here it is to be noted that the dimension of surface energy and the surface tension are same. Next, what are the now some numerical problems based on surface energy. Next, what are the factors which affect the surface tension of a liquid? Number 1, temperature. The surface tension of almost all liquids decreases with the rise in temperature. It is seen that at a particular temperature, the surface tension of liquid becomes 0. That temperature is called critical temperature. Next, surface tension also depends upon the impurities. The presence of impurities either on the liquid surface or dissolved in it considerably affect the force of surface tension. Number 1, if a liquid contains inorganic soluble substance, then surface tension of the liquid increases. অর্থাৎ যদি কোনো অজৈব পদার্থ কোনো তরলের মধ্যে দ্রবীভূত অবস্থা থাকে, তবে তার সারফেস টেনশন বৃদ্ধি পায়। যেমন if sodium chloride is dissolved in water, surface tension of water increases. Next, if a liquid contains dissolved organic substance, then its surface tension decreases. For example, surface tension of soap water is much smaller than pure water. Next, some impurities which do not dissolve completely in the liquid decrease the surface tension. For example, presence of oil or fat in water reduces the surface tension. Next, due to presence of electric charge on the surface of a liquid, the surface tension of the liquid also decreases. Next, the medium above the liquid surface. The surface tension of a liquid depends on the nature of the medium presence above the liquid surface. So we can see surface tension varies with different parameters. Now, few applications of surface tension. We know that the surface tension of soap solution is less. That's why it can spread over large areas within the clothes, and it can wash the clothes effectively. Next, if the soap solution of warm water is taken, surface tension decreases again due to the increase in temperature. So washing of clothes become more easier. Next, surface tension prevents water from passing through the pores of an umbrella. অর্থাৎ ছাতার কাপড়ের ছিদ্র দিয়ে জল কিন্তু কখনো ভেতরে ঢুকে যায় না, তার কারণ হলো সারফেস টেনশন। Antiseptics like Dettol have low surface tension so that they spread faster. Next, insects can walk on water surface due to surface tension of water. So all of these are few examples of surface tension. That's all for the day. Thank you.